Hi everyone. Today we are going to start with our new series Design and Analysis of Algorithm. Design and Analysis of Algorithm. Before starting this video, I would like to share what is the plan for this series. In this series, we are going to start from very basics of algorithms, like what is algorithms, what are the properties of algorithm, what are efficiency of algorithm, and then we'll move with space complexity, time complexity, and many other design approaches. And I'm targeting for this series to cover almost around 150 plus algorithms. If you have a special request of any algorithm to be add on in this series, do let me know in comment section, and please do like, share and subscribe. Though this is a new series, I will try to accommodate all possible algorithms, and I'll try to explain them in a layman terms so that you understand the basic concepts of each algorithm or design approach, right? So don't worry about it. It is a day zero video. So if you are new to the programming languages, then also you can bear with me and have a good start with me. All right. So let's start with design and analysis of algorithm. Let's understand the meaning of these words. What you mean by design, what you mean by analysis, and what you mean by algorithms, right? So let's start with the very basic stuff called algorithms. So what are algorithms, right? What is the meaning of algorithm? So you see a lot of complex coding programs, right? Then you say some people say this is nothing but some XYZ algorithm, right? You must have heard a lot of algorithm exist, right? So algorithm is nothing but it is just a step by step, in a layman terms, a step by step way to solve any problem. So it is nothing but it's a step by step way to solve any problem. It's a very basic, right? Algorithm is nothing but it's a step by step way to solve any problem, or you can say it's an instruction to solve a problem, or you can say it's a method to solve a problem, right? Or a computation steps that transform input to output, right? You give an input, there will be some logic going behind it, and then you get the output, right? So don't go with other fancy words. The best way is step by step way to solve a problem, right? So for example, I just give a small example, right? For example, you have to construct a house, right? You have to make a home, right? So what do you think, right? What all steps you think you need to achieve a home, right? I think first step will be like you have to buy a land, right? After that, I think you need to uh, get the layout, get the layout, or you can say architecture of it. Then might be you need some raw material for that. Once your architecture is final, you may need a raw material. After raw material, you will be hiring people to construct the house. So I am just writing the construction, and I think after that you will be giving a final touch, or I can say interior and other stuff, and then you say it's done, and at last you say it's done, right? So actually now this is a algorithm to make the house. So we say this is the algo for house construction. Hooray, you got an way to design your algorithm. So now you can make your own algorithm. You can solve a real world problem by creating your own algorithm, and you can do a patent of it, right? So that's why, so basic is nothing but you have to understand that algorithm means step by step way to solve a problem. So you can have your own algorithm tomorrow, right? If you solve some novel complex problem, right? So Did you understand what this algorithm word means? Right? Now this okay. So you may be thinking that I gave literally a layman example. Let me give you one simple example. Okay. For example, you need to find the area of a triangle. Let's say find the area of the triangle. Okay. Now to find the area of a triangle, what you will start? What you will be needing, right? You will be starting the algorithm. Then what you're going to do? You need three sides of a triangle. So for that you need one side, second side, and third side. So need three sides of a triangle. Three sides of a triangle. Okay. After that, what you're going to need it? You should know the formula of a triangle, right? Apply formula of a triangle, and fourth point is get the area. And fifth is end. Right? Now your computation is done, so you can end the process. Right? So this is again an algorithm. So what happened is you needed a triangle. Let's say if you talk about A, B, and C, you need three sides, and you have to apply a formula. So it depends upon you what kind of problem you are solving. If you are solving a right angle triangle problem, so what formula you will be needing? Half base into height. So there you just need two stuff, so you not be needing the three stuff. Then the other is Heron's formula. If you know this formula, it's the under root s minus a, s minus b, and s minus c. So this is again a formula, and then here also you have to define what is s. So s is nothing but a plus b plus c. So whatever the formula you write, right? So you have to define those stuff, correct? So whatever the formula uses, either the first one or the second one, you need to apply the formula, and then you get the area. So if you compute with this formula, then it's also okay. If you compute with this formula, then it's also okay, and you get the area of the triangle at the end. So you are understanding, right? So what's the catch here? Catch is that algorithm is nothing but the step-by-step way of solving a problem, correct? So here this thing becomes the input, and getting the area becomes the output. So in some of the standard books, it says that it's a sequence of computation. It's a sequence of computation steps that transform some input to some output, right? So you have some input, you do some computation in between, and then you get the output. So depending upon what reference you are taking, the thing will change, right? I think you understand now. Don't worry, as we go with the algorithms, we'll may understand more and more basics, and we'll try to see the standard algorithm existing. So to know them, we should know what is algorithm, and hence I think we have covered it properly, right? So there is one thing, so you understand it, right? Let me just again go through this example, right? What you are going to see here is we are taking three variables. If you don't know variables, be with me, we'll be covering the basics, don't worry about it. We are storing those things into some stuff called as data structure. Can be integer, can be character, whatever, it depends upon us, right? Let me consider as an integer these values as 2, 4, and 7, something like that. And then again here we are might get a double fraction, like you might get a fraction here, right? So let me consider it as we are getting integer, so this will be again an integer, right? So you need something to store those values, right? So what happens is any problem exists, whenever any problem exists, right? Whenever any problem exists, we can solve with the help of algorithms. Now those algorithms is just not algorithm if you have something to store, that is the data structure. This is a very finite notation of algorithm. So whenever you have any problem and you have some algorithm plus you have some data structure, you have used some data structure in the algorithm, Then in this next step you get the program. Program is nothing but a executable form. Then you that program computes something. So computation happens with what? This computation. So right now I just told you that computation happens with two elements. Either the input, then you give some input, you get some output. So you give some input here and you get some output here, right? So this is nothing but called as notion of algorithm. So it's very easy to understand. Nothing but any problem can be divided into algorithm, and to store them stuff in it we need data structures, which becomes a program. So for example, if I'm writing int a, int b, c, right, then I'm writing int sum, right, then I'm writing some, oh sorry, area, and then area I'm defining as uh, half into b into c or something like that, right? So depending upon, so this becomes the program, and then the computation, this happens computation. Input is the abc and output will be your area, correct? So these stuff, all right. I hope you are understanding it. If not, be patient and let's be with the video and we'll see the next stuff, right? The next stuff is the properties of algorithm. Properties of algorithms. So you now understands what is algorithm, what are the notions of algorithm, how algorithm actually works. Now let's talk about properties of algorithm here, because in coming future you might need one of its property and you will be solving many stuff with the efficiency, right? You may need efficiency of algorithms, right? So that covers in the properties of algorithm. The first property is input. So you should have a finite and a dedicated input. You should have an input. Second is the output. You must get the output, whatever the input, according to that you must get the finite and desired output. Then third we have is finiteness. Finiteness means your program or your algorithm should terminate, right? It should not keep on going into a loop. It should come to a end. It should conclude, right? When it start, it takes input. When it ends, it gives output. When it is in between the computation, finiteness means. So finiteness means it should terminate somewhere logically. It should terminate. For example, in this, if you talk about this, getting the area, right, it will print the area and it will complete. That's it. It will not keep on going executing again and again same program, right? Unless you give a condition like that, right? If you are using a while loop and other stuff and you keep on going through and it's never ending, it does not becomes an algorithm, because you are not coming to a conclusion. Algorithm should have its starting and ending point defined, right? Then it becomes useless, it's not meaningful, right? So it should be finiteness. And the fourth important property is definiteness. That is, it should be very clear. The every step, so I say it's a step by step way, right? Every step should be clear, and every step means every instruction to be clear. You should know that for calculating area you need a formula of s minus a, s minus b, s minus c, and also you should know what is s, so, and what is a, what is b, what is c. You should aware of all these stuff. That is why it becomes definiteness. And the fifth very important property is called as effectiveness, and this we are going to discuss in detail in the next video, that is efficiency of algorithm. Nothing but time complexity and space complexity, what are they, how to calculate for any of the algorithms, right? Those in detailed discussion we are going to see in the next video. So effectiveness is nothing but whatever the desired output you are getting, right? Whatever the desired output you are getting, so how effective is that, like how fast you are getting and how efficiently you're getting? Are you putting lot of efforts to get the desired output, or it's very easy to get that, right? In terms of space, another thing we are going to talk in the next video. So let it make it simple and subtle. That what is algorithm? Algorithm is nothing but a step-by-step way of solving a problem. And what are the properties of algorithm we have seen. Okay, while going to the next video, let me also introduce you with the next two terminologies. So I says design and analysis of algorithm. Design and analysis of algorithm. So we have covered what do you mean by the word algorithm, but we are still yet to cover design and analysis. So analysis also, let me tell you, analysis is nothing but measure of effectiveness. Is nothing but measure of effectiveness. That is, you will be calculating time complexities and the space complexities, right? So analysis means you are going to analyze how the algorithms work, in which fashion they work, in which kind of design approaches they work. And design means what kind of design approaches they are using. So I've just mentioned design approaches, like how they are designed. So there are some standard design approaches. So let me tell you a few of them. The very basic and most used is the brute force. It is a layman approach that everyone going to know this brute force. Then there are some more important, that is dynamic programming. It is the heart of the algorithms. So we'll see what all these approaches, and then we'll analyze and then we'll design the algorithms. So that is why it says design and analysis of algorithm, right? So let me write some of the design approaches. You might know divide and conquer. We are going to see divide and conquer, and then in these terms we are going to see the algorithms. Transform and conquer is also there. It's a mixture of it. Okay, then we have decrease and conquer. Decrease and conquer. We also have backtracking. Yeah, we have to roll back, so backtracking and many others, right? In coming videos we are going to discuss all these things. Yeah, greedy methods, so many, right? We are going to see all the algorithms of these kind of design approaches, and we have to calculate, we have to analyze, that is time complexity and space complexity we'll be using. Thank you for watching this video. In the next video we are going to cover the efficiency of algorithm. That is nothing but how to calculate, or what is time and space complexity and how to calculate them. And then we are going to continue our series. Again, please do like, share and subscribe, as in this we are going to cover 150 plus algorithms. So do let me know if you need some special algorithms to be added in the series. Do let me know in the comment section. Thank you.